Objective: to describe molecular and ionic solids. Crystalline substances can be described based on the type of particles they are made of and the type of chemical bond between them. They can be classified as molecular solids, ionic solids, metallic solids, and covalent solids. Let us begin with molecular solids. Molecular solids. The constituent particles of molecular solids are either atoms or molecules. These atoms or molecules are held together by van der Waals forces rather than by ionic or covalent bonds. Based on the nature of intermolecular forces of attraction, molecular solids are further classified as non-polar molecular solids, polar molecular solids, and hydrogen-bonded molecular solids. Non-polar molecular solids. They are made up of either atoms, as in argon and helium, or molecules formed by non-polar covalent bonds, as in hydrogen, chlorine, and iodine. In non-polar molecular solids, atoms or molecules are held together by weak dispersion or London forces. As a result, they exist as soft solids and have low melting and boiling points. Hence, most of them exist as liquids or gases at room temperature and normal atmospheric pressure. Furthermore, the distribution of electrons in non-polar molecular solids is asymmetrical. Therefore, there is no abundance of charge on either side. Opposite charges cancel each other out. Hence, they act as non-conductors of electricity. In polar molecular solids, molecules are formed by polar covalent bonds. The molecules are held together by relatively stronger dipole-dipole interactions. As a result, these solids have relatively high melting and boiling points. However, they exist as gases or liquids at room temperature and normal atmospheric pressure. Just like non-polar molecular solids, polar molecular solids are soft and non-conductors of electricity. Solid sulfur dioxide and solid hydrochloric acid are some examples of polar molecular solids. In hydrogen-bonded molecular solids, molecules are formed by polar covalent bonds. But the bonded atoms in these molecules are essentially hydrogen and a highly electronegative atom such as fluorine, oxygen, or nitrogen. Examples for hydrogen-bonded molecular solids include ice and solid hydrofluoric acid. Molecules in these solids are held together by strong hydrogen bonds. Due to the strong bonding, these solids have high melting points compared to non-polar and polar molecular solids. They too are non-conductors of electricity. They exist as soft solids or highly volatile liquids at room temperature and normal atmospheric pressure. Ionic solids. The other type of crystalline solids are ionic solids. Ions are the constituent particles of ionic solids. Such solids are formed by the three-dimensional arrangement of cations and anions bound by strong Coulombic electrostatic forces. Some examples of ionic solids are sodium chloride, cesium chloride, and zinc sulfide. Ionic solids are hard and brittle and have high melting and boiling points. This is attributed to strong electrostatic forces of attraction. Since the ions are not free to move about, they are electrical insulators in the solid state. Let's summarize.